Welcome to 3Q Tech Networking, the series of networking videos. You're listening to Naveen, and I'll be with you throughout this entire video series. So, here we have a lot of things to share about technology of networking. So, some of you may be the fresher here to uh, to this world of network, but I suggest please sit completely on one series of the complete video so that you will gain the entire knowledge of the things, the knowledge which is shared in this series of videos. If you are a fresher, don't worry, we are going from the scratch. So now let's start. So today we have agenda of the series 1. Here we going to complete the history, something the past which is happened, which is helping us to learn something about the new thing and the new technology. So and how the LAN was built, local area network was built, and the types of networking and the topologies, the different kind of networking models, scope of network, LAN WAN, the hardware devices and network cabling, the crimping, the laying of cable, everything. So and this model covers very basic of internet networking. We will start a little bit with history that describe how internet networking industry evolved. So we will then move to section that describe how LAN was built, essentially the networking components like NIC card, cables, uh, the hardware components. So we will then cover LAN topologies, and finally we will discuss something about the key networking devices, that's a hardware devices, the hub, bridge, switch, routers, the etc. And my dear friends, I'll the one things please keep it in mind. This series, the first series, is complete on overview only, and it will familiarize you with much of the vocabulary you hear with regards to network, and some of the concept are covered in more detail in the next parts and the next series. So before going to history, let us uh, see what is computer networking. So this is the basic. So let us see what is computer networking. So computer networking is a very simple. It is a set of computers connected together for the purpose of sharing the resource, and the most common resource shared today in uh, connection to the internet. Our the day will start and day will end with the internet. So today is the lifestyle of all of us, and other the shared resource can also be included like printer or the file servers, the application servers, etc. But what I can say is the internet itself can be considered as a computer network. So today we are learning computer networking, but what is the use of learning, and what is the use of learning the networking? So networking, I'll keep it in a two different stages. One is personal and one is a professional. So what the help we get by learning the networking for our professional. Professionally, I can say as a professional computer network engineer, it plays major role in your professional work. For example, if you are running any business, the business cost effective will be very less if you include the networking in your business. Example like your you have hundreds of files in a one corner of world, and you want to share this to the other corners of the world. You can easily share if you have the network and if you have the communication medium. Otherwise it would be very much difficult for sharing the file resources to the different part of world. And using the networking, it will be very much effective and efficient along with end to end support. So if something happen the wrong, in one corner of the pad, you can easily rectify the problem sitting in a remote location. So that is the accessibility given from the networking. And coming to a personal usage, personal uh, 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 benefits. uh, Daily we use Google, daily we use WhatsApp, daily we use Facebook, daily we use emails, and lot of other applications too, online application, online gaming applications. How these are all possible? How these are all possible? This is only because of networking. Only because of networking. If there was no networking, we couldn't have this much of accessibility and a world under our palm. I hope we are going to rule this complete world in the next stages. Let us go and learn something about history, the how, and also how industry came about. So, from historical perspective, electronic communication has an eventually has been around a long time. Beginning with Samuel Morse, he sent a first telegraph message from Washington D.C. to Baltimore MD. It's almost 37 miles away uh, on May 24, 1844, and the message was very simple. What hath God wrought? What hath God wrought? In less than 25 years later, Alexander Graham Bell invented the telephone. So beaten out a competitor to the patent office only by couple of hours on Valentine's Day in 1867. Everybody knows what happened that day. This led to the development of ultimate analog network, and that's called as telephone system. The next is the first bit oriented language device was developed by Emil Baudot, that is the printing telegraph. It is a bit oriented. We mean that device send a pulse of electricity with either zero or the positive or no voltage, the zero or positive voltage. These machines did not use Morse code, and but the Baudot used the 5 level code sent as a 5 pulse down the wire of each character transmitted. The machine did not encoding and decoding, eliminating the need of operator at the both the end of the wire. For the first time, electronic message could be sent by anyone. These were the early networks. The later the network, the telephone analogy was had some further developments. Uh, it's really the telephone network that has had a greatest impact on how business communicated and connected today. Until it is 1985, the Bell Telephone Company, now it is known as AT&T. So AT&T is one of the 17th largest mobile telecom operator in the world as on 2016, and this AT&T owned the telephone network from end to end. It represented phenomenal network, the largest than the still the largest today. Let us take a look at some additional development in the communication industry that had a direct impact on networking industry today. So in 1966, an individual named called Carter, 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 invented a special device that attached to a telephone receiver that would be allowing the construction worker to talk over the telephone from two-way radio system. So the Bell telephone had a problem with this and sued, and eventually it got lost. As a result, in 1975, the Federal Communication Commission ruled that device could attach to the phone system if they meet certain standards and specification. Those specifications were approved in 1977, and became known as FCC Part 68. In fact, years ago, you could look at the other side of the telephone not manufactured by Bell and see the Part 68 stamp approval. This ruling eventually led to breakup of American Telephone and Telegraph in 1984, thus creating a 9 regional Bell operating companies like uh, Pacific Bell, Bell Atlantic, Bell South, Mountain Bell, etc. So the breakup of this complete AT&T in 1984 opened the door for other competitors in the telecommunication market. The companies like Microwave Communication, INC, and Sprint. Today, you and me make a phone call across the country. It may go through these 4 different carrier network in order to make the connection. So that is the huge network of these 4 companies ruling this worldwide. Now let us take a look what was happened in the computer industry at this time. So here what we have came across and what we have seen, this is the part of networking industry, and the same time we will check on computer industry. So in computer industry, it was almost 1960 and 1970s. Traditional computer communication was centralized around the mainframe host. As we all know, the mainframe contained all the application needed by the sender as well as the file management and even printing. This centralized computer environment used low speed access lines that tied terminal to the host. This largest mainframe digital signal pulse of electricity or zeros and ones, what we call as a binary, to pass the information from the terminal to the host. The information processed in the host was all were the digital. So briefing very simple. The low speed access lines were analog signals, and the computers, as we all know, this works on a digital or a binary form. So this brought about the problem. What is the problem? The telephone industry want to use the computer to switch calls faster, and computer industry wanted to connect remote user to the mainframe using the telephone services. But the telephone network speed analog and computer speaks digital. Let us take a closer look at this problem. Digital signals are seen as zeros and ones. The signal is either on or off, whereas analog signals are like audio tones. For example, high pitched sequence, when you hear, you accidentally call a fax machines. So in order for the computer world to use the service of the telephone system, a conversion of a signal had occurred. Can you guess what is the solution for this? Can you guess? If you have guessed, let us check what is the right answer. It's a modem. The solution was a modem, or we can call it as a modulator or demodulator. The modem takes the digital signal from the computer and modulates the signal into analog format. So in sending the information from the desktop computer to the host using ports, the ports are called or it can be called as plain old telephone services, and the modem takes the digital signal from the computer and modulates the signal into analog to go through the telephone system. From the telephone system, the analog signal go through the go to the modem. Then in the modem it is processed, the signal then converted to the digital form and given to the mainframe host. And this process, given some kind of solution, at least for for the distance problem to the certain extent. But we have some other problem also. So another problem was how to connect multiple lines to a single cable. The technology solution is a multiplexing or a mux. What we can call to do is a multiplexing is we can take multiple remote terminal, connect them to our single central site, our signal mainframe at the central site, but we can do it all over the communication, single channel of communication as a single line. So what you see is we have some new terminology here in our diagram. uh, Here we can see the signal center side with refer to the broadband, and the connection that is referred to as a broadband connection, because whenever we talk about the broadband, we are thinking about the carrying multiple communication channel over the single communication pipe. So we are saying here that we have multiple communication channel in 4 terminals at the remote side going back to the single center side over the one common channel. But again, the case of 4 definition of broadband, here we are referring to the fact that we have 4 communication channel, one of each remote terminal over the single physical path. So now out of that end station at the terminal, you see we have a term, the baseband. So, and what you mean by the term baseband is, in one example, between the terminal and the multiplexer, we have a single communication channel per wire. So each of these wires leading to multiplexer has a dedicated channel or dedicated path. Now the function of multiplexer is to take each of this baseband path and break up and allocate the time slots. What that allow us to do is allocate a time slot per terminal. So each terminal has its own slot across the common baseband connection. So between the remote terminal and the settled mainframe site. So that is the function of multiplexer, it to allocate the time slot, then also on the other side put the piece of back together for the delivery of the mainframe. So mux is our fundamental concept here. Let us look at different way of doing muxing. You can again see the term here, baseband and the broadband. Again the analogy that you are using here, that is in the case of baseband, what I said, we had a single communication channel per physical path. An example of baseband technology, or probably familiar with the Ethernet. For an example, most implementation of Ethernet using baseband technology, we have single communication channel going over the single path or a single physical cable. On the other hand, on the bottom part of our network diagram, you can refer to the broadband, and the analogy here we would be multiple trains inside with multiple trains inside the single tunnel. So maybe we see that in the real world we probably familiar with the broadband as some of we are doing every day, that is a cable TV. With the cable TV, we have multiple channels coming over the single cable. We plug a single cable into a back of our TV over the signal or single cable. Certainly, we know we can get 50, 100, 500 more channels over the single cable. So the cable TV is a good example for broadband. So given as an additional of multiplexing and the use of modem, let's see how we can grow our network. So using all the technology available, companies were able to uh, team up the phone company and tie branch office to the headquarters. The speeds of data transfer were often slow and were still dependent on the speed and the capacity of the host of the computer at the headquarters site. So the phone company were also available and able to offer the lease line and develop connection. With the lease line, the companies paid for continuous to the host computers. Companies using dial-up connection paid only for the time used. Dial-up connection were perfect for the small office or a branches. And the birth of the personal computer in 1981 really fueled the explosion of networking marketplace. No longer were people dependent on mainframe for application, file storage, processing or printing. The PC gave user incredible freedom and the power. So the 70s and 80s saw the beginning of the internet. The internet was what we know it today began with as an ARPANET, the Advanced Research Project Agency Network, built by and division of Department of Defense essentially in the mid of 60s through a grant funded research by universities and companies. The first actual packet switch network was built by BBN. It was used by universities and the federal government to exchange information and research. Many local area networks connected to the ARPANET and TCP/IP. So I think a TCP/IP you are listening is the very new word. I'll tell you what is TCP/IP and all in the next stages. So TCP/IP it was developed in 1974 and standard for the transmission control protocol, internet protocol. So when it comes to protocols and uh, the OSI layer, I'll completely briefing you on this TCP/IP. So coming to the ARPANET and this history, the ARPANET was shut down on 1990 due to network technology. Uh, More I can say it is a newer network technology that needs and the greater bandwidth requirement to the backbone. So backbone we can consider it as the spinal cord of for the human being. So from backbone from world one part to another part where the huge bandwidth carrying and distributing to the part of world through the connected channels. So in late 70s the NSF net, the National Science Foundation network was developed. So this network relied on supercomputers in San Diego, Boulder, Champaign, Pittsburgh, Ithaca, and Princeton. So each of six supercomputers had a microcomputers tied to which spoke TCP/IP. The microcomputer really handled all the access to the backbone of the internet. Essentially, the network was overlaid from the word. Can you guess? Can you guess what is a word called? Word go. The word go, it was, our backbone was overloaded with this word. And the further development in networking leads to a design of um, an ANS net, so advanced network and service networks. So ANS net was a joint effort by MCI, Merit and IBM specifically for commercial purpose. The large network was sold on a it is sold on 1995 to AOL. So it is the National Science Foundation. They awarded contract to four major network access providers. that is specifically speaking about uh, San Francisco company, which is had a Pacific Bell, and the Chicago company called Ameritech, and Washington company called as MFS, and the Spirit in the New York City. By the mid of 80s, the collection of network began to known as a network internet in the university circles. So the TCP/IP remains the glue that holds it together. In Jan to 1992, the Internet Society was formed, a misleading name since the internet is really the place of anarchy. It is controlled by those who have the fast line and can give customer the great service today. I can say it is the greatest. So the primary internet related application used today including email, news, remote login, retrieval, file transfer, and the world wide web access and the development. So with a complete growth, the growth and development of the internet came to the need of speed and the bandwidth. Companies wants to take the advantage of the ability to move the information around the world very quickly. So the this information comes in the form of voice and data, the large files which increase the demand of the network. So in the future, global internet working will provide an environment of emerges uh, application that will require even greater amount of bandwidth. If you have a doubt the future of the global internet working, consider this: the internet is doubling in size about every 11 months. Every 11 months the internet size is getting doubled. So then you can think, so before it was 2G, now it's 3G, presently 4G, coming it's 5G. So the speed is getting double. So what we have learned, uh, I think it was a bit boring, but it's a informative the series, the first part. Now next we will move to the land technology, the interesting one and the basic one. In the next our the part we are going to learn the land technology. So meet you in next session. Thank you.